it's pretty clear at this point that we have moved beyond linear change. The days of linear change, which is what evolutionarily we're prepared to deal with, really, those are behind us. So we're no longer able to predict the near future based on the recent past. We've entered the arena of abrupt climate change. Things are spinning out of control on the climate front at the global level at a very rapid rate. It appears that methane coming out of the Arctic Ocean has gone exponential.
Edward O. Wilson, conservation biologist at Harvard University, predicts that only 10 million years after an extinction level event, there have been 5 so far, we're in the midst of the 6th great extinction, only 10 million years after an extinction level event, we have a vibrant green planet again. 10 million years. The more seeds we can plant now, the more species we save now, the greater likelihood that in only 10 million years we'll have a vibrant planet again.
Of change greatly exceed anything recorded in paleo records by at least 10 to 30 times. Greenland and Antarctic ice caps are melting and calving at unprecedented and accelerating rates. Large chunks will soon slide into the ocean, causing tsunamis and abrupt sea level rise, swamping coastlands. We are heading to a much warmer world, abruptly, within decades. The transition will be brutal for civilization.
You look at 500 million years of the last 500 million years of planetary history, you see 2 states that are stable over very long periods of time, tens of millions of years. And it's Ice Age and about 10 degrees centigrade above Ice Age. And really very few stable states between those two, and not very stable, as in happened once or twice in that entire 500 million years. So really there's hothouse Earth and there's Ice Age Earth, and there's very little stepwise action in between. Now we don't know what many of those negative feedbacks are. We don't know what causes Earth to go from hothouse to Ice Age frequently in a very short period of time. So there must be these self-reinforcing feedback loops that cause the thing to get cooler as it gets cooler as well. We don't understand much about that. But they must exist, or we would have gone Venus a long time ago.
The Eemian temperature, so this is about 130,000 years ago, between 130,000 and 118,000 years ago or so. The temperature at that time, as measured from oxygen isotopes in ice cores on both Greenland and Antarctica, for example, we can get temperature proxies. So the temperature at most in the in this Eemian period was 1 degree Celsius warmer than today, or in other words, 2 degrees Celsius warmer than the pre-industrial temperature, because we're up from the pre-industrial today about a degree Celsius. Now, some recent work shows that the Eemian temperature may have only been 0.2 or 0.3 degrees Celsius warmer than today. So we're getting very close to this particular state. Now, the CO2 levels during this period, as measured from bubbles in the ice cores, the global CO2 levels were only at about 270 parts per million. So it's not an analog for today, but that period does show how quickly ice sheets can respond and CO2 levels can change, and sea levels can rise.
According to the Astrophysical Journal, for the entire history of the field of astrophysics, astrophysicists believe that we were right in the sweet spot, right in the middle of the habitable zone, right in the middle of the green zone for a sun with the intensity of our sun. But in fact, as it turns out from this relatively recent paper, we're right at the inner edge of the habitable zone. You can see Mars on the right, barely in the habitable zone on the other side. And you can see Venus, the yellow plus sign, just to the left of Earth there. And we know what happened to Venus, right? It went Venus with respect to its atmosphere and became lifeless. And so if we are within 1% of the habitability for a star the likes of our sun, what that means is a relatively minor change in atmospheric chemistry might drive this planet beyond the habitable zone. And this is the bummer part. We haven't made minor changes in atmospheric chemistry on this planet. We've made major changes, increasing carbon dioxide more than 40% since the beginning of the Industrial Revolution, to a level never experienced by humans before, and increasing methane by more than 200% since the beginning of the Industrial Revolution, more than 200%. And again, methane is more than 100 times more powerful a greenhouse gas than carbon dioxide over relatively short temporal spans. And contrary to the contrarian myth that there's been some sort of pause in warming, I'm sure you've heard this from your climate denier friends, in fact, heat has been increasing and it's been stored in the ocean. So yes, land records actually paused, sort of, for a time after 97, 98, the last time there was a big El Nino event which causes the heat to come out of the ocean and on the land. But the ocean is an enormous battery. It stores carbon dioxide and it stores heat. And look what's happened since 97, 98. Heat intake by the ocean has gone up dramatically, even in the deep ocean, more than 700 meters down. There's been an enormous rise in heating. So with the next El Nino, which is underway right now, albeit a weak El Nino currently, there's going to be a lot of heat that comes out of the ocean and overwhelms the land masses. Never mind methane. The amount of carbon dioxide and heat that is stored in the ocean right now is sufficient to cause all sorts of trouble for us in the not too distant future. I want to talk about one of the self-reinforcing feedback loops that have been triggered and that we've become aware of in the last 6 years or so. So I'm going to talk in some detail about methane bubbling out of the Arctic Ocean. The first time it was reported in the referee journal literature was in August 2009, when about 250 plumes of methane hydrates were escaping from the shallow Arctic seabed, likely as a result of a 1 degree increase in temperature. Well, since then, the temperature of the Arctic has been increasing at more than twice the rate of the global average. So the Arctic is warming much more rapidly than the global average, than the rest of the planet. And that helps explain the Rossby wave or meandering jet stream or the polar vortex that you likely have heard about that has been blamed for the never-ending drought in California and also for the record cold and snow experienced on the eastern seaboard over the last couple of winters. Science comes along a little less than a year later and has an article reporting impacts of methane hydrates, the importance of those methane hydrates. Methane hydrates, or clathrates, represent cages around methane molecules. So methane is CH4, or natural gas. And in the shallow Arctic seabed and in permafrost, they are trapped by a clathrate, or a chemical cage. And when that clathrate warms, it breaks open, and CH4, methane, is released into the water column, or worse, into the atmosphere. And so when you see the term hydrate or clathrate, that's what we're talking about, is those chemical cages. Geophysical Research Letters gets on board in 2010, and finally, in a paper by Michael Jennings at the University of Idaho, we see an admission in the refereed journal literature that a suite, not just one, but a suite of amplifying feedback mechanisms, or self-reinforcing feedback loops, or so-called positive feedbacks, such as massive methane leaks from the subsea Arctic Ocean, have engaged. So the self-reinforcing feedback loops are underway. These are feedback loops that feed upon themselves. So the faster they go, the faster they have the potential to go. A good example is ice on the Arctic Ocean, floating ice on the Arctic Ocean, which has been in decline since the beginning of the Industrial Revolution, and most notably within the last 34 years or so. And as the ice gets smaller, it reflects less radiation back up into space, and that open blue water absorbs more of that radiation. And the more it absorbs, the warmer the ocean gets, and so the faster the ice melts, and the faster the ice melts, the less albedo we have, the less reflectance we have going back into space. So it's this mechanism that feeds upon itself. The faster it goes, the faster it's able to go. According to the author of a paper in Nature, July 2013, this is Natalia Shikova, who's been doing field work along with her research partner Igor Sameletov in the Arctic Ocean for about the last decade, and she concludes that a 50 gigaton burp of methane is, quote, highly possible at any time. There would be a 1.3 degree temperature rise conservatively associated with that burp of methane. Finally, NASA gets on board and observes methane plumes up to 150 kilometers across in the Arctic Ocean summer before last. This is huge. You imagine you're in a ship, you're in a sailing ship in the Arctic Ocean, and as far as you can see, every direction, the ocean is bubbling. It's bubbling like beer, or like ginger ale, like carbon dioxide is coming out, but it's actually bubbles of methane that are coming out, as far as you can see in every direction. So observe that quickly, because when you start to breathe that in, you're not going to last very long. Nature Geoscience gets on board, points out that storms accelerate the methane release. Eastern Siberian Arctic shelf is venting a lot more methane now than it was not very long ago, according to this paper. Sam Carana concludes the global average temperature will be above 4°C by 2030 and more than 10°C by 2040. And I want to make a distinction here. When I give the name of a journal or an organization such as the Intergovernmental Panel on Climate Change or NASA from the United States' National Aeronautic and Space Administration, those can be found mostly in the refereed journal article or are put out by the organization. These other ones that have the name of an individual represent projections made by individuals, and they are not published in the refereed journal literature. So quite a clear distinction there. According to Malcolm Light, retired Earth system scientist now living in London, I believe, the Gulf Stream transport rate started a methane hydrate or clathrate gun firing in the Arctic in 2007. So the gun was fired many years ago. According to Paul Beckwith, climate scientist at the University of Ottawa in Canada, we can expect, based on historical events, a 5 to 6°C temperature rise within a decade or two, and he actually pondered a 16°C temperature rise within that same period of time, albeit with respect to the previous ice age. So that's 11 or 12 degrees higher than it is right now. And that makes sense because those are the relatively stable states that Earth has experienced throughout its history. We have ice ages, we have 5 or 6 degrees warmer than ice ages, and we have 11 or 12 degrees warmer than ice ages, and maybe one other one in there. But these are the relatively stable states, and Earth doesn't go gradually from one to the other. The changes tend to be quite abrupt from one relatively stable state to the next. And it could be that we've actually triggered a Venus-style event. It could be that we haven't as well, that Earth will stabilize at some relatively modest temperature, like 5 or 6 or 11 or 12 degrees above where we're at right now.
This is a mess, basically. This is a very strong Super Nino. Look at these temperature anomalies. 4 to 8 degrees is this scale here. Very, very hot water. But the entire Pacific is warm. And there's this is the blob that scientists have been talking about. And there's very warm water. There's huge warm water here. And look at the water up here going up through the Bering Strait. 4 to 8 degrees warmer than normal. And that's been taking out the ice. This is another view. This is Climate Reanalyzer. The El Nino here, the very warm water, and you can get another view. The key thing here is 0.83 degrees Celsius is the anomaly. That's so the whole North Pacific is 0.83 degrees warmer than normal. It takes a huge amount of energy to heat water. This is the surface sea surface temperature, so it's at the surface. But this warm water goes down at least a couple hundred meters. If you calculate the amount of heat that represents, that heat going in the air, sends the temperature soaring. This is a global view, so you get this pattern, and this is typically this warmer area here, cooler here, is a typical El Nino. But there's lots of other stuff going on here. There's nothing normal about this situation. This is Earth Null School, and what you can do is you can see, I can zoom in on here, and you can see that this is the water temperature anomaly, 6 degrees warmer than normal. Look at this really warm water off Greenland, not doing the ice sheets any favors. Really warm water almost up to Svalbard, and in this region, whole region between Svalbard and Iceland. And if we look at the actual temperatures as opposed to the anomalies, then you can see, look how warm this water is, almost 10 degrees Celsius. Really warm water here. And this water is just cutting away, going underneath, cutting away at that ice, because the flow is this way. The sea surface height is higher here, lower here, so you generally get the flow coming through here. This is a view of, this is the Naval Research Lab data. So this is the sea ice thickness. Black being the thickest ice, and then green's about 3.5 meters, and this blue is 2 to 2.5. Okay, so this is the thickness in meters, and what you can see is this is the date, so 2015, the month, the day, and it cycles through about a month. And you can see what happens when it jumps. It starts at the beginning, and look at this ice here, completely destroyed. Okay, and you can see quickly this is happening in a month. So this is July. We still have 2 more cycles. We have another month to mid to late August, and then another month mid to late September. Normally the sea ice minimum is mid-September. So a couple more months of this. So what can happen? I mean, with all this green being hammered, there's almost no black left. There's almost no red left. The idea that remnants of ice will be left here for a long period of time, I'd say throw that out the window. There's not much export through the Fram Strait. It's just melting from warm water underneath and warm air temperatures above. Not too much export through Nair Strait or Fram Strait.
So we wanted to have a conversation. Both of us are generalists in the sense that we don't look at a single aspect of climate change. We look at various aspects. I don't look just at Arctic ice or just at Greenland ice or just at methane release in Antarctica and so on. And Paul is the same way. So we wanted to have this conversation. And I would also encourage other members of academia to have this kind of conversation. We really need to broaden the argument. Which is flask data on methane.
What does that mean?
Okay.
So-
The spikes they took out.
Yeah, they took out the spikes, the data points that indicated exponential release of methane at the Svalbard station. And so those data points were removed. I hear from people all the time, they took out one data point, you're projecting the world based on that data point. No, it was actually a handful of data points. And they said they revised and smoothed the data. But really, it looks to me like they took out those 5 or 6 data points that indicated exponential release of methane from the Svalbard station. That's one station, admittedly, but there are very few stations in the Arctic, and I believe that's the northernmost
Yeah.
one. Can you?
Yeah,
is that correct?
it's one. The northernmost ground station. It could be. I'm not sure.
So it's quite far
There might
north.
be. Trying to think of the latitude of that relative to the high Canadian north, and I think. Yeah, I'd have to check.
So it's very close in any event.
Yeah, yeah. So yeah, so it doesn't make any sense to, like, how can they have this report and not talk about the risks of methane? It just makes no sense at all.
And in their report released Monday, just
Like yesterday,
a week
or
a week ago.
Oh yes,
8 days ago.
Yeah.
I've only read the executive summary, which is long enough in and of itself to occupy me for a
About
month.
60 pages, isn't it?
Yeah.
One
So
summary.
it's a lengthy
Yeah.
document, and the words Arctic ice do not appear. How can
Yeah.
IPCC, which is charged with summarizing and synthesizing relevant information, how can they ignore
Yeah.
Arctic ice?
I don't know. I mean, if you wanted, if you want to do, it would be very, just go get the article, cut and paste it into a Word document. It gives you a word count. Do a search. Search for Arctic, search for methane, search for sea ice. You can see how many times those words appear and see where they appear, and you can do it, very quickly. So, like, the extreme weather is because of declining Arctic sea ice. Right now, the thing is this is cutting edge research. This is new stuff. There hasn't, Jennifer Francis published stuff about it in March of 2013, or March of 2012. And I've been talking about it, and AMEG has been talking about it since we founded 2.5 years ago. It's the reason why a bunch of us, people in the UK, had a conference or got together at a guy's house in the garage or basement or whatever to talk about methane. It was people with all different backgrounds. It was Peter Wadhams is the most visible of us. He's written and been involved in over 300 peer-reviewed publications. He has been on excursions, scientific expeditions in the British military nuclear submarines to go under the ice to measure the thickness of the ice from below using sonars and things. And
Several times, not
he's
just
not
one time.
Yes,
several times.
at least 6, 7, 8. I don't know. At the order of 10 times. I don't remember exactly, but maybe it was 6 or 7. Anyway, the point is he's not just a scientist. He's not just somebody on a blog that is supportably pushing facts on global warming can say, oh, this guy is an extremist, or he's a loony, or like it's just mind-boggling. How can these experts not be treated more seriously? And Peter has been saying that the sea ice in the Arctic will likely be gone by September 2016 for the first time, plus or minus 3 years, which is it's not something Peter's doing on his own. I mean, the highest resolution model on the regional model on the Arctic sea ice by the U.S. graduate the U.S. Navy Postgraduate Research Center or whatever, NRL, the Maslowski model, is saying 2016 plus or minus 3 years, and they came out with that prediction in 2007. Interestingly enough, many people are arguing that this landmark paper by Hansen et al. is painting a picture that is worse than the reality. But I'm probably one of the few people that would point out that in this 66-page document, there was no mention at all of increasing methane emissions, and there was no mention directly of Arctic temperature amplification and the resulting effect on slowing and causing waviness of the jet streams. And these are things that myself and AMEG, Arctic Methane Emergency Group, have been talking about for a long time, that the trigger of the whole thing is the extremely rapid warming of the Arctic, leading to loss of sea ice within the next few years, causing greatly accelerated release of methane from the permafrost and subsea sediments, for example, on the eastern Siberian Arctic shelf, which the Russians have been mentioned. So, as extensive and as well considered as the Hansen et al. Paper is, I personally was extremely surprised that there was no indication at all, no mention of these particular things: methane, the jet stream waviness, and specifically the Arctic temperature amplification, which is causing temperatures in the high Arctic to be, on average about 6 times higher than the global average warming temperature, even higher compared to the temperature change in the equator.